Hello, welcome.
Welcome. What is this continuous deployment now? We have continuous delivery, continuous integration. Everything is continuous in this world. This Are we in a continuity? Is it like this? So
I think,
explain,
I think.
please. What is continuous deployment?
Hello, Adrian.
Hey,
You're in a good mood, I see.
I need to. I stream.
Um, you know, for a very long time, I kept confusing continuous delivery and continuous deployment. So today's episode is for people who are confused, who are confused like me, or at least we can talk about.
So the regular
Um,
software engineer.
yeah, I would say so. Um, I just saw a recent LinkedIn post regarding software engineering and um, who to follow, newsletters, etc. The typical kind of
Mhm.
LinkedIn influencer post. And I had this information that there's like 230 million software engineers. I think with 230 million software engineers in the world, there's probably someone who doesn't know what continuous integration means, or what continuous deployment means, or what continuous
Or
delivery
maybe
means.
two. Maybe two. Yeah.
Maybe two. Maybe two.
Maybe we both, right? Both of us.
Both of us, yes, yes,
We
and
are the
everybody
only
else
ones who
knows.
only think we know, but we actually streaming something and we have no
That's
clue
new.
about
That's
it.
new. Yes. So continuous delivery is very much on point for us. But I would like to talk about continuous deployment as well, not just about continuous delivery. And there was this recent book that came out by Valentina Servil, Continuous Deployment. There we go. Let me hold it up. Um, that talks about essentially what continuous delivery is. I will keep mixing them up. I'm sorry. But what continuous delivery is from an XP perspective,
Hmm.
right? So most people, I think, have heard about the acronym CI/CD.
Hmm.
That you have continuous integration slash continuous something, continuous integration slash continuous deployment, or continuous integration slash continuous delivery. Now I don't know why we have the CI/CD acronym, right? Like if you're doing, right, you know what I mean?
Yeah.
Like why do we have the CI/CD acronym? Like, are you doing continuous deployment or not? Like, like
I'm a media engineer. I grew up with CD is corporate design. And then someone came along with the CICD. So now we had
I'm a
another
millennial. I
CD,
grew up
and
with
then we
CD
had
being
another
compact disc.
CD. There are three CDs in my profession. It's a little bit like,
So
please write it
when I
down
was young,
correctly,
we
right?
went from CD to DVD. I'm the generation that skipped Blu-ray. So now we have.
CD. Yeah, compact disc. It's actually a compact disc. So
Oh,
how
we
do
have
we
a
do
we have a
compact
we have
disc?
a comment in chat. Is that continuous deployment is very difficult for me, especially if there's database change. Can you talk about special cases, especially for zero off time? I'm assuming zero downtime, right? Zero downtime deployments. Um, is that Thomas?
Yeah, it's Thomas. Yeah,
Okay.
Thomas
Um,
Eisinger.
sorry, I don't have LinkedIn open right now. Um, are we streaming to LinkedIn?
Yes, we are.
Did you change that?
I changed that. Yeah.
Okay, good.
It's good, yeah.
All good.
Hi,
Cool.
LinkedIn.
Hi, LinkedIn. um,
Okay, what is continuous?
so
So no, not what is, but he's actually asking how continuous deployment is very difficult for him.
yeah,
And I know that from the past that zero
yeah.
downtime deployments weren't a standard thing several years ago.
Mm-hmm,
It
mm-hmm,
started with Kubernetes and Docker Swarm
mm-hmm.
to become something which is usable.
Yeah.
And would you say that, in your opinion, first of all, continuous deployment, so being able to do rolling updates, which is essentially the basis would be the rolling update or more advanced versions of that. But do you think that's first of all a standard out there when you see
That's a
your own
good
experience?
question. So I think continuous delivery is a standard. That doesn't mean that everybody's doing it, right? So continuous delivery is a very good standard,
Hmm.
but the vast majority of organizations, I would say, are not doing continuous delivery.
Yeah, but continuous delivery and a rolling update as a minimum, in my
So,
opinion, are connected. So you can't really do continuous delivery.
and that's a
Sorry,
great
continuous
question, and
deployment.
I think, and I don't think I can answer that question without going into the acronyms. Right, so
Yeah.
continuous integration for me is integrating, on a main branch frequently. What is CI for you?
For me.
What does CI? Yeah, for you,
Yeah,
what
for
does
me, it's the
CI mean?
integration part. That is actually had nothing to do with shipping or delivering. It is
Yeah.
more like so the colleagues and me, right? We are
Hmm.
working on trunk, which is basically a
Yep.
branch, and we're working together,
Hmm.
integrating that branch, running tests against that branch, making
Hmm.
sure it can build, and those kind of things. That is first of all the integration. That is
Yeah.
so closely related to the small batches, iterative approach, and continuous delivery, which is the
Hmm.
idea that we are able to deliver at any time.
So it's a good
Yeah,
thing that
I
you're
would say
already
so.
mentioning it. So you mentioned a few phrases there that you're integrating on a main branch, even if you are using feature branches, that you're integrating them frequently, regularly,
Mhm.
continuously. Well, um, then you also said iterative, which is interesting, right? So continuous integration and continuous delivery,
Mhm.
I think for me, okay. So you mentioned iterations. Okay, I like that. I will return to that. I will continue with the definitions. So I think continuous integration, delivery, deployment. Integration is the least strict continuous practice, and deployment is the most strict continuous practice. Would you agree with that?
Yeah, yeah, so far.
So it's integration, delivery, deployment. Like if you're like stack ranking them by difficulty, continuous deployment would be the most difficult. Continuous delivery is something in the middle, and then continuous integration is like the minimum.
Continuous deployment, sometimes called the brave mode of continuous delivery.
Okay, good, good,
Yeah.
good. Okay, good. So CI means you're integrating onto a main branch. So what does main branch mean? Because people who use Gitflow are also
Let's call it trunk branch, not main branch,
I,
because sometimes
so
trunk isn't main.
yes. And sometimes main isn't the main branch. So if you're using Gitflow, your main branch is not main, and people are super confused. If you're using Gitflow, your main branch is okay. Who here in chat is using Gitflow or
Hands
is
up,
aware? Hands up. Who here in chat is
admit,
using
please.
Gitflow?
Admit.
Yes. Ben
It's
just
it's
joined.
time. It's
Hey
time to
Ben.
admit.
So if you're here on YouTube, on Substack, or on LinkedIn, if you're using Gitflow or know somebody who is using Gitflow, what is your main branch? Main branch from the perspective of continuous integration, delivery, deployment. What is the main branch? Hi Ben. So I'll wait 10 seconds.
LinkedIn does take 15 seconds, I think, until they
Okay.
actually reach the message. I have prepared a little board, for a Miro board. I could display it if you like, and just continue to draw something.
Sure. I just want to have this. Okay. So if you're using Gitflow,
Mm-hmm.
for the perspective of continuous delivery and deployment, your main branch is the release branch. That's that's the main branch.
Yeah.
Because we need to know where is the releasable artifact being stored. That's the main branch. Your main branch is not main. Your main branch is not master. Your main branch is not develop. Those are intermediaries towards the main artifact branch that stores your deployable artifacts, and that is the release branch. And people get this wrong. People do feature branches and then they merge to develop, and they think that that's continuous integration. It is not. It is the main branch that is going out to production. Now it's weird with Gitflow. What Gitflow is doing weirdly is that it has an artifact. So the repository for what goes out to production for historical reasons, so the tags are stored on the release branch. So usually people rebase the release branch so that it has like a very neat history that doesn't necessarily follow chronologically. It just stores the releases. I find that weird. Like when I did Gitflow, quite a long time ago, there was a tendency to keep like a neat, like a pretty archive on the release branch. But that is very annoying because that is essentially your main branch. And I know people will disagree with me. If you disagree, happy to have a chat. But we can have that chat offline. Wait, Brian is here. Brian says, drives me crazy that people think CI is I down merged. I down merged. Interesting. I don't know what that means, Brian. If you could explain. But yeah, so if you're using CI/CD Git flow, your main branch is the release branch. It's not develop. It's not main. Because we need to look at it from the perspective of where is the main releasable artifact being built from, and once it is built, where is it saved, and where is the main testing going on? And usually, I hope it's happening on the release branch, not on the feature branch prior to it getting merged, because that's also but that's a different topic. That's how to set up a CI/CD pipeline so that it enables continuous delivery and deployment. That is a completely different topic. I don't want to talk that today. I see. Brian says down merged means pull from main. Yeah, down merged. Yeah, that you're pulling from main. That integration is I'm on my feature branch, and integration is I merged. I resolved conflicts with main. Yeah, I agree. Like that's in a way either incompetent and sometimes toxic, where people think
continuous delivery the need to merge from main back to your trunk in any way seems a little bit weird in general.
No, but I mean,
it means that someone has done something wrong in that moment.
Yeah, so CI/CD beginners or developers who are not doing continuous delivery and continuous deployment, who are using CI/CD tooling with something like Gitflow, they will often think that integration is when they pull their conflicts from main. I have seen this. So I have not seen the usage of the word down merged, but I have observed this behavior. And it's really tough mental shift for that person. And it's hard to talk to them about continuous delivery because they don't know that they're not doing it. And they're not really looking to do it because they're not coming at it from they're never coming at it from the right question. Never buggered you. I like that.
Okay.
So you asked something really interesting, which is does continuous deployment require rolling updates? And I would say no. Rolling updates are one of the strategies of how you can achieve continuous deployment once you've landed at the continuous delivery stage. So continuous integration
you can continue. So the idea, what I mean is, you have a mechanic in place, an automation which helps you to seamlessly deploy a new change. This is what I actually mean by rolling updates. Not
it depends on scope.
Rolling updates.
So when you go from let's go back to definitions. CI integration. Integration means merging onto and possibly destroying the feature branch or your local branch. That will then represent the place where the deployable artifact will be built from. So the release artifact, not the testing artifact, not the thing that you deploy on stage and then you still fiddle with it, but the release artifact, where it will be built from. That's a release branch. That's not. I'm not going to go into it again. Continuous delivery is then a step up. Continuous delivery is this idea that the humans are releasing into the main branch, and continuous delivery is that there exists automation that decides that when a human does, so CI is manual. There's always a human involved. There's always a human involved who presses merge. So CI is not automation. CD, delivery, is when you then remove the human from the equation. Is that a next step up? There's a human, they have pressed merge, and now there's a machine involved. And that machine will basically decide, do I create a release artifact from what landed or not? do I create a release candidate from what is now being presented on main? And that machine will try to deliver a releasable artifact from what was integrated. That's delivery. It won't deploy it, but it will prepare the release artifact. And it will prepare it completely without human intervention. That's CD. While we're talking about this, I would like to pull up minimum CD because I would like to pull up. So Brian wrote most of the stuff on minimum CD, and I would like to pull up his definition of. So he uses the terminology deployable and releasable, right? So continuous delivery is going from a state of here's the code. The code in itself is just source, not releasable. And continuous delivery is the continuous production of building the releasable thing. Going from source code to binary. But it's very crude, right? So in a web world, that might also involve just preparing the web artifact. So maybe not the code in the binary itself, but maybe the Docker images that it'll run on. So that's delivery. Do you agree? Like, did I say anything stupid, or is there something I missed?
No, it's not just actually not the way I used to describe it my way. But
Okay, good. Then please, how do you explain it?
So for me, continuous delivery is more the approach to. So it's less about the technique. And I think that's one of the aspects of minimal viable CD as well. It doesn't focus on the exact how implementation, so you can implement it in many different ways. But the idea is always to be in a releasable state. This is what if that releasable state means you have a binary artifact ready to release, or you even release it automatically, is still continuous delivery. But you could basically call it continuous deployment in the same way. But so that's where a little bit of SharePoint is. But in continuous delivery are not, let's say, it's not mandatory to actually deliver it to a client, to the final client, but to something. So this is what I remembered as well. So it must be delivered somewhere, and if it's just for a staging system where you test it, stakeholders test it, and you get a feedback. So the feedback cycle must be at least at minimum complete. And if I now talk nonsense, we have someone in the audience who actually wrote that stuff, and he could tell if we are both right or wrong in that moment, right? But this is how I actually used the definition. And that was what was confusing me, because before I really got into those definitions myself, I was basically I was thinking that continuous deployment is that, right? Because it is very similar, but in continuous deployment you go all out. You actually go to the client. So if someone is actually when integration is done, you go out.
So that's interesting, because I also thought of that, and I still think that way, right? Because if you look at the book Continuous Delivery, it does use the continuous deployment, what I would call continuous deployment definition of the word continuous delivery. That we're actually following full path to production. Like, to me, I like to use the word continuous deployment, same way Valentina does in her book, to denote the idea that we are doing full path to production. And I like that definition because it's sort of consistent. I like using, if you're deploying, I like using the word deployment for it. Now, continuous delivery in that sense can have a wider meaning. Now, I put it in the middle, but it can also include deployment, right? So you mentioned a example where we can deploy to staging, and that would still be considered continuous delivery. And I think in that sense, continuous delivery and continuous deployment are much more vague and a little bit interchangeable than integration and delivery. I think that like the hard line is between CI and the other two, and the line between delivery and deployment is a bit blurry. That's how I would put it. So I wouldn't focus too much on the definitions between delivery and deployment. Not a little bit, but not too much. And deployment for me is when full path to production is actually being automated. without with a veto system, essentially. So the machine will assume that when you have a releasable artifact, it is valuable to release, unless a human has vetoed it. Right? And I like to think that most organizations that don't practice continuous deployment are basically having a CI/CD pipeline where that veto is constantly in effect. Right? So a human has said, yeah, don't deploy it ever automatically. But we do have the pipeline that is able to do so. And if you don't have the pipeline that is able to do so, then you're not even doing continuous delivery, right? So if a human has to deploy it, then that not only does not pass the definition for continuous delivery, but also doesn't pass the definition for continuous deployment, right? So the active delivery also has to be automated, right? So
would the world be a worse one if we would just merge those words?
No, I think not. I think they have. Now, I think so. You asked an interesting question, right? Regarding is rolling updates necessary for continuous deployment? And I would say no, because there are many different strategies for how to achieve. Thomas asked this: zero off time, zero downtime deployments. One of them might be rolling updates. One of them might be canary releases. I personally prefer canary releases. One of them might be green-blue releases. One of them might be just, if you're targeting a sharded node, you can expand, do canary plus and basically just keep both versions in production.
Sorry, again, this is why I specified this. I don't mean Kubernetes rolling update strategy. The standard strategy.
I'm also not.
I really mean that
it in
seamless
the
updates are necessary to have a continuous. You can't just shut down your system towards users every time to make an update, because you don't know how often you update. You can update 10 times a minute or once an hour.
Well, let's simplify it, right? So a rolling update. Let's say you have your old let's do it one server at a time. You have your old server. The type of update is basically, do you modify the server as it is running? Do you spawn another server while it is running? And then, a new server with a new version. And then you basically make a decision of, do you put this one online while this one is still online? Do you take the old one offline before you put it online? Or do you take it offline after this one is online? So a rolling update is when both of them are up, and then you take the old one offline when the new one is already online. So it sort of transitions into and gently replaces it.
But if I hear that, to be honest, I'm a legacy person and I'm a modern world person. The first thing I do is remove legacy in that moment and go to the modern world, because continuous deployment and delivery in old world is possible but not nice. So it is it's an awkward thing when I think on some of those constructs we still manage with Windows and Windows service combined with PHP and some Apache service and 3 types of databases. That's horrible.
But ultimately, what Kubernetes does is essentially what you did manually with something like PHP FPM, for example, where you had to decide, okay, am I reloading, restarting, or am I doing it gracefully, or am I hard stopping, waiting, and then hard starting?
Yeah, that's what tools like Octopus for the Windows world did before Kubernetes.
Exactly.
But that is not nice. That is not really continuous deployment, because it is not continuous. If it doesn't, if it stops, it's not continuous, even for a minute. That's what I mean by that.
If it's possible to drop requests, then it is not continuous. So I disagree on the word continuous here from the perspective of development. It is continuous development, but it is not a zero downtime deployment, right? So you can do deployments with downtime and do continuous delivery. That's possible. I'm not saying you can do continuous deployment.
Delivery, yes, but not continuous deployment.
No, you can also do continuous deployment and have the downtime, right? So the continuous deployment means that
just like your clients,
Yes, of course. Now, you and I consider that to be
have a good
unprofessional.
customer support when you do that.
Exactly. We consider that to be in bad taste, right? Or in like a bad habit from like an engineering culture perspective. But continuous deployment does not require you to have no downtime. It's possible there is downtime, right? And the most naive
Of course,
implementations have downtime.
I think the ideal the idea here is to create some value. We
I
shouldn't
agree.
encourage anyone
I
to
agree,
have
but
downtime.
I don't want to put the ideal into the definition of the term. Right? So the term continuous deployment and continuous delivery requires you to close the feedback loop as pragmatically as possible. If that requires you to have downtime, sure, you'll have downtime. Right? So, but the number one goal is to close the feedback loop. So full path to production. So we reach a real human being who's using the real system in real time. And now a better standard above that, an improvement in the standard above that, is real path to production, closing the feedback loop, and not dropping any requests. Right? So that would be like a more reasonable standard for continuous deployment.
But let's quickly get back to the question here. So,
Yeah.
Because it's actually
Databases. Yeah, databases. And Thomas asked this question. Brian also mentions database question. Definitely worth discussing. Evolutionary DB change doesn't seem to be well understood. Yeah. I tried to talk about this on LinkedIn last year. I think it was the anniversary of continuous DB refactoring or continuous refactoring. It was this idea of evolutionary DB change by Martin Fowler, one of his books. And I don't know why, but it was really like it sparked a lot of flame wars on LinkedIn by people who don't do who don't do evolutionary DB, right? So from like those old school.
I think you need to explain this, because what is evolutionary DB?
Do we have even the time? I'm
so
sad.
Is it in short? Because I don't know the term, but I would like to describe it how we do it, because it sounds a little bit like what you actually should do. So you have a database version, right? So that's the current state of the schema, right? And you have the problem that during the rolling update, let's take the simple rolling update, you need to do migrations in some form or another. So the schema changes, but you only have one database and you have two separate versions at the time running. So if it fails on all these kind of things, you need to have something in between which makes it possible to actually run that. And what we do is to make sure that version A and version B can run both at the same time, and they are backwards compatible in a way. That's the same thing as you do it with REST APIs and these kind of things. You don't build in breaking changes. And if you have a breaking change, you need to have a breaking change you cannot avoid, can happen sometimes. You need to plan some form of downtime window, right?
So that's not evolutionary anymore, right?
Then explain that, what it is actually.
So I think evolution, so continuous rollouts for databases, and I finally get to answer Thomas's question. It's like, how do we do database changes? Is that whenever you're doing breaking database changes, so breaking database changes, right? So if you're familiar with the object-oriented world, I think that would make the most sense. In object-oriented programming, we have types. A extends B. Is a rectangle a square, or I think people use this example the most. Shapes, dogs, is a dog an animal? Is a dog a cow? Like those hierarchies, the diamonds that they do with multiple inheritance and things like that for composition. Or is like an apple is a fruit, a banana is a fruit. How do they extend? How are they compatible? Has to be substitutability, right? The LSP, the L in solid, talks about this issue. So when we're talking about continuous, imagine the old schema and the new schema being different types. Think of it as type in like your programming language, your classes. When we're talking about continuous, like evolutionary design, we are talking about such a rollout, such a deployment, that the new version is a perfect substitute for the old version. with regards to whatever code is running in production.
A perfect substitute.
Yes, so that it is a perfectly compatible substitute, right? So
compatible substitute, because
yes,
substitute is not compatible. The
no,
word
so
substitute means a replacement.
Yes, so it is a replacement, right? So when we talk about substitutability in software design, in object-oriented inherit and in type systems, or if you go to mathematics, right? We have this idea of variance, and things can be covariant, contravariant, invariant, and is it bivariant? I think that's the yes.
I act now like I need to answer some chat messages.
Right, so contravariance and covariance is what we really care about, right? So it is this idea that, and I actually, I'm sorry that I brought this up, but I don't know. I need some terminology to explain it. So it's basically, I like Okravi's new book on object-oriented design, specifically this, and he has a great example. So you have, let's say, a vending machine, like a fruit juicer. If I have a juice function that needs a fruit juicer and it produces juice, right? So if I have a vending machine, a juicer, and I have a function that requires a juicer. Imagine I have a restaurant and it requires a juicer.
Mm-hmm.
If I have a fruit juicer rather than an apple juicer, right? If I want a fruit juicer and I need to produce juice, then any fruit juicer will do the job, because any fruit juicer produces juice from fruit. The issue is, if you tell me an apple juicer is incompatible with any fruits, an apple juicer can only be used with apples, then that is not a fruit juicer. That is not a perfect substitute for juicing any fruit. So when you're using it in the input, right? It can be okay when you're using it in the output, but not in the input, right? So it is this idea, and this is
it's more like the superset subset thing, isn't it?
It's a superset subset thingy, but it's about covariance and contravariance, right? So the inputs are contrary to the outputs, right? So you want to be. I think I always get these wrong. You want to be looser on your inputs, and you need to be stricter on your outputs, right? So you need to be at least accept the same thing as you did earlier, or more. And what you return needs to be at least that or stricter, but it cannot be looser. So,
but for Thomas now, does he need a fruit juicer or an apple juicer now for his database?
So that's the thing. Right? So when you have a old database and code, there is a variance going on, right? So imagine that the database and your code running on your server, on your active server. Imagine that's just two pieces of software. Forget that one of them is a database. It's just two pieces of software communicating with each other, right? This one has a version, that one has a version. So it is this idea that when I'm doing rolling deployments, in order to do them, when I'm doing changes to the database, I can mess up the dependency, the downstream dependency. The code depends on the database. Usually it's that way. So when you're updating the database, the new database needs to be just as good as the old one, but it can have more behaviors. But it cannot lack any previous behaviors. And it mustn't be stricter on any of the previous behaviors.
But isn't that what I described?
I don't know. This is how I describe it. But no, it's difficult to describe it. Even like, so I don't have. I don't have
in a practical way. So you imagine you have your CI/CD pipeline deployment service in your PaaS platform,
yes.
And the update failed, and you have to roll back. Your database should still work, even though it's already in a new schema, because you have no no possibility for this database to do a transactional rollback for the schema itself. So it should still work. So no matter if you roll forward, backward between those two versions, you shouldn't have any problems with the application. That is how I would describe it in a very simple.
So that's not true. So
What is
when
not
you're
true?
rolling it backwards, the variance changes. So if you want it to work backward and forward, the change needs to be bivariant, and that is a much stricter. It's a much.
And what I mean is, so imagine you have failed the update, but the schema
Yes.
check, the migrations are done, and you roll back.
Yes.
The system
Yeah.
is not allowed to crash. This is what I mean, and this can
Yeah.
be done. So you can actually design APIs and things like this, safe like safe refactoring in AIs. If you know you would have a breaking change,
So
you could basically make
DB
temporary AIs for that APIs. So.
evolutionary DB design, so continuous deployment of databases, has to do with splitting up databases in such a way that any breaking change happens in multiple steps. Right? So when a breaking change means that one of the updates is no longer a substitute for the previous one with regards to a certain version of the software. So you break the chain. Imagine the importance is not between one DB version and the next. Imagine that you have the DB and the software, and the chain goes like this. And when you deploy an incompatible version of the DB, you don't break it on the DB side, you break it on the DB to software side. Right? So because the change was too big. Right? The change has become stricter, contravariant, or invariant with what was previously there. So it is.
I think we're still talking about the same thing.
We are talking about the same thing, right? So, but I just want to highlight that rolling updates are primarily useful, simple. Like we can talk about them in simple terms if we prioritize one direction, because rollbacks don't have the same guarantees. Rollbacks require slightly different guarantees. So when you have a change that is breaking this chain, you break up that change into smaller pieces so that if you merge the 6 changes together, they are still doing the same break, but individually, they have always maintained the chain. So when you do, huge software changes, imagine updating your ORM, and huge database changes, imagine adding a column and dropping an old one. If you deploy both of these at the same time, you will have downtime on both ends if you naively deploy. Updating the new software will be incompatible with the old database. The old database will be incompatible with the new software. The new database is incompatible with the old software, and the old software is incompatible with the new database. So it breaks in every direction, usually, when you do this kind of change. Or imagine that you're breaking a foreign key, and you're going from a one-to-many relationship to a many-to-many relationship with a join table, or a one-to-many relationship with a join table. That is usually this kind of breaking change. So the idea here, evolutionary updates, is breaking up those updates so that you don't do like a big database change and then a big code change, or in the inverse, but you break them up. You do DB code, DB code, DB code, DB code, DB code, DB code, DB code. Like that's the idea. That's the idea how you do that, right? So when you talk about continuous deployment, you do the same thing with regards to everything that has to go out, right? So imagine you have different components. Continuous deployment, at least in this meaning of the word, not in the meaning of the word of delivery. So we're talking about doing zero downtime, rolling updates with trunk-based development. Every component that depends on each other has to be rolled out this way. So if you're rolling out, if your front end has a GraphQL server, you're rolling out changes in such a way that mid-rollout, that version is compatible. And then only when the old version becomes obsolete, do you continue the rollout. That's what a rolling update would actually entail in the Kubernetes sense. That it knows what the dependencies are, and it knows like where the important breakpoints are, where the breakpoints are for, this one depends on that, so I need to like completely replace all instances, and then I can continue, right? So like it's obviously more complicated than that. And I'm not an expert in like what goes on under the hood in Kubernetes. And honestly, I don't want to be like, I don't want to have to understand Kubernetes to that degree.
But especially for most listeners and viewers, like Thomas, for example, there are very simple solutions for that out there. And it's a pretty good idea to not try to add more complexity by having multiple different containers for one
Yeah.
application running, which is not the same commit.
Yeah.
So that is for more complex systems with multiple teams necessary,
Yes.
but it is not a good idea if you just have one team and multiple CI/CD pipelines creating multiple artifacts, which then are sometimes deployed and sometimes not.
Yeah,
That
so-
creates something which is complicated.
Now this creates something interesting.
Yeah.
Right, so continuous delivery and continuous. Brian said no one actually understands Kubernetes. I agree. like my appetite for wanting to understand these systems stopped at around the Docker Swarm to Helm level. Like I went deep.
Great.
Yeah, but then the moment I got deeper into that, and then the moment I had to understand like Kubernetes internals, I was like, oh, okay, too far. Too far. Like that's the dark
most
side.
People who, especially in the startup area, Kubernetes is oftentimes too overpowered, right? So it's a too complicated tool, but for what you actually want to do, Docker Swarm is better. But
Kubernetes to me is like talking to somebody who uses Emacs, and they're trying to explain to you how using macros for everything is the superior way of text editing.
Kubernetes is capable of doing a lot of things, and you just need this tiny subset, which is actually, deploying something and get some form of rolling updates or maybe some more advanced strategies. But most people start with rolling update when it comes to that. And it's very complicated to set these things up yourself. But we have a lot of good systems out there which are actually using Kubernetes these days.
Yeah. So I'm not hating on Kubernetes. I'm just hating on. If you want to do, you don't need complex tooling for continuous deployment. If you think that you in your company can only do continuous deployment if you shove complex tooling down every team's throat, then that's probably not a good solution, right? So and especially not proprietary tooling, that there is some kind of very expensive SaaS product that does CI/CD and it does continuous deployment for you and rollbacks and roll forwards and rolling updates and everything, and that's the only way to do that in every organization is by using that tool. If you have like some kind of like infrastructure team that forces like very complex tools in order for you to do continuous delivery and it's not working out very well, I wouldn't call that like a success. I would treat that as a problem. Continuous deployment can be done very simply, right? So from a delivery perspective, to answer, well, not answer, but like expand on Thomas's question. It's very difficult for me. Of course, it's very difficult for you because continuous deployment is a behavior of reduction. It is a discipline, right? So continuous deployment says, if I'm going to do continuous deployment, there are certain changes that are not allowed for me to do continuous deployment, right? So usually when people don't use continuous deployment, they go in thinking, okay, I need to drop a column in my database. How do I do that continuously, right? So I have a migration. I just dropped a column. I added the new one. Here's the new code. How do I deploy this continuously? Well, continuous delivery doesn't give you a solution for that. Continuous delivery, it's a discipline. By essence of reduction, it says, well, you're not allowed to do that. Because that is one of the things that creates a non-viable, incompatible substitute. And we cannot deploy incompatible substitute continuously, right? So it says that the commit you produced cannot be deployed continuously, so it has to be rejected by definition. So there is no point forward here. You need to go back and redo the commit such that it can be rolled out continuously. That's the whole idea of continuous integration, continuous delivery, and continuous deployment. That it gives you immediate feedback on, hey, the increment you just produced, it cannot be rolled out continuously. And that is the feedback you receive, and it says this is rejected. There is no way of deploying it. unless you're happy pulling everything offline, having some downtime, deploying it, and then pulling it back up. But we're not doing full feedback on. Brian says a rational order of operations gives a solution. Exactly, right? So you have a rationale for what kind of changes need to happen in what kind of order, and what is the maximum sort of magnitude of that change. That is at the heart of chunk-based development. That is at the heart of continuous integration. That is at the heart of, I don't know, continuous delivery with ATDD. It's even at the heart of event modeling, right? If you're planning your projects using event modeling, you're essentially saying, well, here's my slices, and my slices need to be self-contained, and that's how we roll them out. And the deltas go from a system that is stable to another system that is stable. If you created a migration as a commit where the database is in a weird state, then that is not in itself a stable state. You go from stable state to unstable state, and then hopefully everything will go okay and you go back to stable state. But you need to look at stable state across the entire system, not just with locality. So a database can be stable by putting the schema update in a transaction, or like having a reasonable rollback scenario. There are some databases that cannot do schema updates atomically, or at least they're not ACID compliant, right? So that there might be something, I don't know, dropping a key, you can't undo that because you lose state of the old keys, or dropping an index, for example. In other databases, adding an index is actually extremely dangerous, and you cannot do it in a transaction because adding the key immediately creates an index. Now, there are some databases where you can say, just add the key and don't run the index. Like, just add the index and don't index anything right now. Do all the changes first and then do the indexes. Right? So that's database specific. But that is not enough. Like, your change needs to be sensible across the entire vertical. So code, front end, back end, infrastructure, security, firewall, router, database, and all the multiple databases, if we're talking microservices here, then every update, at least from commit A to commit B, from commit 10 to commit 11, from one neighbor to the other, has to be a perfect substitute. So when you encounter what continuous delivery and continuous deployment is all about, at least in my perspective, is when you encounter such a large batch that cannot be deployed safely, so that you have produced an unsafe substitute, that there are now rules of how to break this up into a safe substitute, so that you break up one large unsafe deploy into a series of perfectly compatible deploys. That's the point.
But what we have missed is simple steps for continuous deployment so far. So we lost ourselves, or have lost ourselves a little bit into describing things, and this one problem Thomas just mentioned. But now let's go into the actual topic, because we are now an hour in. Simple steps for continuous deployment. So that is, I think, what we should talk about today, at least for some minutes. And so now we know what continuous deployment is. Actually, I stick with it's the brave mode of continuous delivery, but they are so you could interchange them. It would work for most companies. So it's but now we have that. And what would be the simple steps for a company?
Yeah.
So what is a company right now? Let's say a small company who can work fast, break things, go ahead, right? And a more, let's say, more traditional, more established company where a lot of users are, and there is an outcry if there is something going wrong during the continuous deployment process. So let's take A and B, so small and large company, and now explain to us, Dennis, what is, for the small companies, the interesting part for simple steps for continuous deployment?
For a very simple company who wants simple steps, I would say deploy everything front to back. Right? So that means, in an event modeling sense, deploy everything right to left. If you're doing horizontal slicing, right, so you're slicing them by layer. Usually what you would do is you would roll out the database, then you would roll out the code for the backend, then you would roll out the front end. That, in essence, if you're using it that way, there are now two solutions. Now, the harder solution is to vertically slice. Is to say each vertical slice in itself will be self-contained, and that each slice will live on its own server, and everything will be self-contained on one server. But generally, even if you are doing vertical slicing, the different layers still live in different servers. So my recommendation would be, don't just go from horizontal slicing straight to vertical slicing, because that would be very difficult to reason about. Go front to back first, right? So the rule that I say is, hey, who needs the backend? Well, the front end. Okay. So let's deploy the consumer always before we deploy the producer. That's what I mean front to back, right? That is a very simple rule that lends itself to an extremely simple mindset of how we roll out the changes, right? So if I have a new backend server and it requires a new database column, I don't deploy the database until there is need for the column. Some kind of write, some kind of read. And because that means that I have to deploy the need first, I need to deploy the demand side first. And that demand side has to work in absence of the new change. That is the simplest rule that you can follow. Always consumer side first. Because usually when I give this exercise, now, Valentina also goes to lengths about describing different scenarios for this. Usually when you do vertical slicing, you're not doing incremental, you're not doing iterative development, you're doing incremental development. So that doesn't mean that you take a complex problem and the problem is non-functional at A, and then you go A1, A2, A3, A4, A5, and then you go 0, 0, 0, 0, 0, 100%. It's like flat, 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 flat works. That's iterative development, where you just take a large problem and then you deploy 20% and it's unfunctional, and then you deploy 40% and it's unfunctional, and then you deploy 60% and it's unfunctional, 80, and then the last deploy is functional. That is not continuous delivery. That is not continuous deployment, right? That can be iterative development. A lot of teams do Scrum that way, where they say, oh, well, we didn't deploy anything, but here's like progress on something. No, done means feedback cycle. The feedback cycle is closed. That's what they care about. So vertical slicing is incremental. It means we're not talking about delivering 20% of something. We're talking about delivering a fully functional version of the system that can be produced in 20% of the time. That's incremental. That's not iterative. That means that the next increment we will produce, we will plan and develop from the current increment that we are now producing. Right? So we're not doing 20% more. So it's not like you're doing, you have 5 bullet points and you do number 1, and then you do number 2, and then you do number 3, and then you do number 4, and then you have number 5. But instead you do, I have one goal, I have one item to make, and I will deploy a version of that system that has, in a fifth of the time, that has a very simple behavior. And then I will build on that simple behavior. If it works, I will get feedback on it, and then I will get more complex behavior from it in the same time, with another 20% of the time allocated. This is a simple example. That's where you're going with vertical slicing, right? But that is a much bigger mindset shift than alleviating the pain caused by horizontal slicing. When you're doing horizontal slicing, you're slicing by layer. You're doing by database, then you do backend, then if you have microservices, you do multiple backends, then you might have multiple front ends, you might have the Android app, the iPhone app, the web app, a typical web app scenario, for example, for like a SaaS company. And then you deploy them back to front. That creates all kinds of problems, because deploying them back to the front implies that the thing ahead of us does no longer need to work with the old system, right? So the thing ahead of us doesn't need to work with the old version of the database anymore. So we're just going to bump the database version, and then if it's okay, we're just going to bump it forward. And that always causes problems. So if you want to have a simple step, my simplest step to continuous delivery, or simple steps, 2 steps, is forbid deploying the producer before the consumer. Right? So I would always deploy, hey, we need a new field in the database. Okay, I would say no. Does the user have access to the database, like direct access to the database? No. Okay, then we're not doing that. Right? Like, how does it affect the user? I would always come at it from the perspective of, okay, well, let's hard code the data first from the front end, for example, or let's feature flag it. Right? Let's give the feature flag that if you're doing a structural change, for example, in a database or in a backend setting, we're changing the backend API and we're updating the front end. Or they add a feature flag that can query both versions of the front end. Right? That's what I would start with. Because I'm creating demand. And then I roll that out. It still works, defaults to the old version. And if I call the new version, it throws an error. Or I've also deployed a simple stub for the new version that returns just enough not to throw an error on that path of the front end. And then the next release is deploying the actual path on the backend, but the backend might need database changes as well. So we do the same kind of flagging on the database, but because the consumer side is controlled, there isn't some like weird front end that we don't know about that will suddenly discover this API and start calling it. The feature flag on the front end was sufficient, right? So we can just spin up the new endpoint or create a new path of the endpoint that's fully backward compatible or not accidentally queryable. That's more important, by the old version of the system. And then you have that in parallel. And then only that new version needs the new database. And only when that new version has been deployed to production and you already got feedback on the front end on what it would look like if we had actually built it, then you start building the backend system. This is very much
pretty much complicated for a very small company.
Sure.
So that the explanation you gave is already for me for larger companies who have multiple services, who have a lot of, let's say, problems when something goes wrong. So they need to have a clear strategy, what goes first. And it's a little bit like climbing a mountain where you have your nails in the rock, right? So in case something happens, you can get a step back without falling down. And a little bit like the startups are just doing that on the climbing wall. And if they fall down, there is a mattress down there. And it's a little bit like that. This is what I asked in the beginning, because let's say people like Thomas, right? They are more in a smaller space area where other people have, let's say, a lot of risk if they do something. And sometimes people forget to mention that for every company there's context and you have risk management, which means that you can. So let's quickly take a look at the Meta principle, or it was Facebook back then. Basically, run fast, fail fast. What was it? I forgot it actually, but you know what I mean. It's the idea that
move fast and break things, I think.
Exactly, right?
Yeah.
So the idea is that you're actually allowed to break something, but you should avoid that, of course. And for me, it's a little bit like when I think of smaller companies, which is everything between 5 to 20, 30 people in a company in total. Most of the times, your systems, this is what I see out there, this is what I see as, they are quite simple. So the most easiest thing is to get the things out and make sure if you know you make a breaking change, you have more attention in the deployment.
You want simple steps to continue the deployment. Well, the simplest step is to have downtime. Right, so the simplest.
I wouldn't say you have, but you could have downtime. So that is how I would rephrase it in a more modern way.
So the simplest step, because downtime is not important. Downtime in itself. What is important is availability in the part of the day when availability is needed. So that means, so it means how many requests. Not in theory, not speculated requests, but actual requests am I dropping because of a deployment? If the number of requests is very low, and if you can predict where those requests will be, if you can predict when the requests will be zero, or if you're in an air-gapped system always, right, then you can deploy. And you can have downtime, and in theory, you won't have downtime because nobody's querying you. Now, the issue is, if you're doing that strategy, then you have no valid feedback mechanism for who has tried to query you and you were down and you were expecting them to be, they were expecting you to be up. You expected them to not want to call you at that time. But you don't know because you were down. So you need some kind of monitoring system on their end, right? So now the simplest thing and I know this might be controversial, but from like a perspective of continuous delivery in Spirit, it is more, for a small company, it is more important to close the feedback loop than it is to chase some 99.9999% availability.
Yeah.
Right? So closing the feedback loop and maybe eating a little bit of downtime is more important, I think, in the context of like startups and growing, scaling companies than doing perfect zero downtime.
Doing brave mode, right?
Yeah, doing brave mode
Get
in like
things
some
out.
weird, crazy setting.
Because you
It's like,
become better. You become better at it as a team. So if you dare
yeah,
more to deploy,
yeah,
then you will make less errors, right? So
yeah.
sometimes it
So
still
this
happens,
mentality,
right?
so what is simple? You wanted simple steps. Step one, prioritize closing the feedback loop over downtime. And step two, deploy things front to back. So consumer side first. Which this means that you deploy the thing that will crash with the old version first, because it forces you to build the consumer in such a way that it works with the current and the previous version. Current being the new one, right?
So if we speak from consumer and provider in that moment, we could
So a
simplify that
front
down
end
to
is a
front end,
consumer
back
of
end.
the back end. The
Yeah.
back end is a consumer of the database. You know,
So
that's like,
you would basically deploy front end before back end in that moment.
yeah. No. I would develop in such a way, I would prioritize the work in such a way and shape the work in such a way that that would have to be mandatory. Which means that the developer, I wouldn't just deploy any commit like that, obviously, right? So because that produces a deployment pipeline where some things
You need a
cannot be deployed.
deployment person who is managing this like a train station.
Yes, and of course, and this isn't to do with the deployment. This is to do with the mindset and the mentality of the developers, right? So the developers, before they start working, they need to understand that this is a strategy that we have chosen. It's very simple, but when they are building their new feature and they're thinking of removing something on the back end, that's the front end implementation has to go out first. So the front end has to work with both states, and it has to be developed that way, deployed at least once, so feedback gathered at least once, integrated at least once, deployed to a real user, even if it's a real user on a canary setup on only 1% of the traffic. And when that is stable, then we can do the rest. Then we can go to full path to production on the other scoped things. Scope might be different types of infrastructure. Scope might be different types of backends when it comes to microservices, or the different types of databases when it comes to microservices. You know, like a microservice, backend microservice might have a cache database, a state database, an event store database, a message queue database, or several, right? So the scoping can differ.
Yeah.
But think of it as you have a coffee machine, it produces coffee. We always go cup first. Like we never hit the button and produce coffee when the cups aren't there. So we always go cup first. And we go cup first, even if the coffee machine is incapable of producing coffee.
I think
But
that
we
that
do
entire topic explains why small batches and small increments are so important. Because the larger your batch is, for example, a week of work which you want to
And
deploy,
I'm going to say
the
something
more
controversial.
complicated it is. What?
I'm going to say something controversial here. And this, I think, is in line with Tony's comments. I usually try to simplify the review processes before a customer is allowed to go more fancy with technical solutions. No need to scratch your head on things that should not exist. And I think that has to do with like the incremental stuff, like the continuous, the vertical slicing, etc. At least that's how I understood it, Tony. Please correct me if I'm wrong. In that same vein, you don't need small batches to do continuous delivery. The small batches are an output of wanting to do continuous delivery. So if I want my updates to be continuous and front to back, I need to shape them in a way and deploy them in a way so there's an order to deploying things that if I follow them diligently and reject PRs that don't follow that rule, that the result of working that way is small batches. So the small batches are an output of doing continuous delivery. It's not something you have to do. It is the result of the work when you're taking these rules seriously.
Yeah, but so what I can say is, for me personally,
Let me put it differently.
I want to say something as well, right?
Okay.
Because you're talking all day long. No, just saying. So continuous deployment, the most easiest way to do is to actually to have one branch, and you release that branch at the same time. So imagine you have front and back end. This is the minimum thing. Well, these days Next.js might have just one thing, right? But let's go with the traditional approach of having those two sites, and you have a database which need to be migrated, and a caching layer which is a big thing to update. You basically go all out at the same time, because we said, you are allowed to break something, especially in a smaller company you are. And it is extremely easy, and I can say out of my own experience for so many years now, it is rarely that something happens. And most of the time, it's a fail of the pipeline itself to deploy something, and it's rolling back automatically. That is the most of the cases. It is not a software problem, because you have some integration system in between, which had already run it at least once before it goes to production.
Yeah.
That is what I can say, extremely simple, but it's working the same way like the production one. And that is what I wanted to add as the most simple version I know, is to deploy everything at the same time, because I don't even know personally how to get the front end out before the back end without using more complex pipelines like GitHub Actions, which wait for each other to get those things done.
So I'm not saying using more complex pipelines. What I mean is just feature flagging incompatible changes. Yeah, that is a good solution. Or feature gating them, right?
Yeah, of course, that is, but that is not how I understood your approach.
No, but my point is that you cannot deploy it, the front end before the back end, if the mode of operation is inherently incompatible with the old back end. So you have to feature flag it in some way, or feature gate it, or hide the, fall back at least.
Why is it not possible?
Well, because it'll have downtime. If I deploy the front end before the back end and it's incompatible, it'll have. If I deploy the front end, it'll be downtime until I also deploy the back end.
Yeah, this is the reason why I say deploy it at the same time, and when they are as an application healthy.
That doesn't solve the problem. I agree with you. I agree with you in, like, from the perspective of pragmatism, I agree with you. But that requires everything to be in the same delivery artifact.
Yes.
And that makes sense if you're also avoiding microservices, or if you have all of your microservices managed by some Kubernetes-like orchestration thing.
Yeah, this is what we do. We use a PaaS solution, and we have microservices.
And that PaaS solution might be complex tooling that enables like that kind of like limited CD, but I wouldn't call that simple. That makes this step simple, but it requires complex tooling. Like there must be at least one person in the company.
But this tooling is widely available these days. So I
but that doesn't mean it's not complex. I know, but you understand the complex tooling, right? So
yeah.
So somebody in your company who doesn't understand the tooling will not be able to do continuous delivery. For me, that is not simple anymore. That's just you taken a complex problem and sort of found a way to work with it and gain experience with it. But if you want to do continuous delivery, then the simplest tooling is just having like a feature flag, a feature gate is a freaking if statement somewhere, right? Or if you're doing object-oriented programming, it is a form of subtype polymorphism, right? So like the new thing will be a perfect substitute of the old thing on the consumer side, right? So I think if you're going simplicity, a feature flag on the front end is always the simplest. Now, a feature flag on the front end is extremely annoying
as long as you remove them.
That's a different. Again, we want simple. Like we didn't say that simple doesn't automatically mean sensible, perfect, professional. Like right now we have a very low standard. We have simple, right? It's just simple. Like enterprise level, very professional, very much, covers all edge cases. I think that's more than we can cover in one episode. But when it comes to simplicity, I think giving the developer who writes the code the most power would come first. So no tooling, right? So no app spec in DigitalOcean, no Kubernetes rolling updates, etc. Right? It's just that there is no complex tooling. It might give somebody some headaches. Kalian mentioned simple is not easy. It doesn't mean that it's gonna be everything is gonna be okay. It just means that there is least amount of cognitive processing necessary for any kind of tooling setup. Ben asked on the Substack chat, can one of you describe the complete tech tools needed for CI/CD for a small startup? I think you shouldn't need any tooling. I think you having some form of GitHub Actions equivalent or a Jenkins server, that is that, and following the simple rules that I mentioned, that would be enough. That would be minimum.
I disagree entirely with you in that moment. I'm totally disagreeing.
Let's talk about that.
Good, because so startups are primarily, in the vast majority of cases, developers and not ops people. That's one of the things. So Tony Menzel is an ops person. I know that from LinkedIn.
Awesome.
So
awesome.
He's a typical person who can.
This is not for Tony. This is not for Tony. If you have an ops person.
So
if you have an ops person, we're talking scale up.
Yeah, of course, normally, yeah. But
normally,
because very small teams normally don't have these people supporting. Sometimes they have them because the CTO is somehow capable of doing that and is doing that. But instead, this person should actually focus on development, because this is where actually value comes in, and that's extremely important business-wise. And if you remove that problem from your, let's say, tooling and infrastructure, starting from the CI/CD pipeline, let's say Docker repositories, pipeline, I mentioned that, deployment process, rollback, forward, backward, rollbacks, these kind of compatibilities, a little bit of monitoring, insights, logs. That's it, right? That's let's say the rough thing I call. And if that is in a PaaS solution available for you, and you only need to understand the complexity of actually a Docker compose file or a Docker stack file, doesn't matter, that's the same thing. If you understand this type of complexity, which is doable for every developer, for every standard programmer, right? Then I think it is extremely helpful to you to do CD, whatever D it is, for you very easy, because you don't have these problems, and you basically pass these problems to a PaaS solution which is available. And it is the same thing like platform engineering has been done for scale-ups or for larger organizations or something like that, just that you are so small that you can use the standardized package without someone needs to customize that on the context of your teams, which is necessary for scale-ups later to get all the things together. But especially smaller companies, I saw that now so often, they are very easy to run if you take away the burden, because I see so many small company CTOs who are actually still developers, and instead of doing business, they not even doing programming, they do ops, which doesn't make sense at all to me.
I mean, right now you sound like somebody who's sponsored by DigitalOcean.
I'm not sponsored by DigitalOcean.
I know, but I'm saying you sound like someone who's sponsored by DigitalOcean. So I think if you want to do continuous delivery, and you can't do continuous delivery and continuous deployment without some kind of PaaS solution, that's like that's not a necessary constraint for me. I've been doing continuous delivery before cloud existed, and you don't need, you can do continuous delivery with FTP, right?
But you don't want to do this.
Again, what you want and what you don't want, I'm okay with. I know you're using DigitalOcean for a lot of stuff, and I know you're using DigitalOcean for especially to avoid Terraform and
there are other solutions as well which you can use as PaaS solutions.
I know, but I understand your point. You're saying a small company should not waste time on building pipelines and building software, like in-house tooling, that have commoditized solutions. I agree with you. With regards to how they spend their time, I would say absolutely not. Absolutely not building your own deployment pipeline software. Not yet. Not yet. Like, build your own process, please. Optimize your process. But try to build your process and have some constraints and requirements, and then see which PaaS solution fits that bill. But when your requirements change, be ready to change the PaaS solution. That would be my warning to startups, because I've seen a lot of.
I always say stay agnostic.
I've seen a lot of startups start off on AWS because they received AWS from their freaking VC as credits, and then they went on AWS, used way too much what that AWS has offered. They didn't document what they needed, what was mandatory, and what was just available at hand, and they started using non-mandatory stuff that was at hand. And then when they run out of credits, they go bankrupt. Right? So I've seen both ends here.
Infrastructure as a service clients.
Yes. So, and it's very, like, as a startup, you're very quickly there. There's something. So from like I don't know how to phrase this actually, because in essence I agree with you, but also, okay, so I would agree with you when I had a very low opinion of my product engineering quality and a very big demand of my CTO, right? So if I knew that my CTO would know not to, right, so if I'm a CEO and I have a CTO, I'm like, okay, we should spend very little time on platform engineering right now and a lot in either product market fit or growth, or just getting the value stream optimized. We're exploring, we want to find leverage, we want to create the impression that the company deserves an extremely high valuation at this point. And we're not going to get there by building our own Kubernetes, right? And we're not Slack. Slack was an exception. You know, they wanted to build a game and they built a chat system, and then they sold the chat system and not the game. Like, again, unicorn. These things happen, but you're probably not the next Slack. I would agree with you if you had a very low standard for product engineering and a very high standard for pragmatism on the CTO side. But let's imagine the roles are reversed. If I had a very low standard for the CTO and a very high standard for product engineering, because I end up coaching either one of these two extremes. This is what I see. This is the kind of people I work with. I would always tell them, if you don't know how to roll it out, you now have two solutions. Either you invest into a CI/CD pipeline, like a PaaS solution that helps you roll it out. That's, I think, where you're coming from. I would come at it from a slightly different perspective, from a more product-oriented perspective. I would think about it from the perspective of, if we don't know how to build it incrementally, we're not building it. So if the idea is that it has to be built, and then if it cannot be deployed continuously, we just ship it when it's done, I would say, no, that's worse. Right? So, for example, if you're doing some kind of legacy modernization, or if you're doing some kind of, I don't know, a startup that tries to like break into a market of like old legacy systems and modernize some kind of process in there. And if you're coming with this argument that, hey, we have a solution and we just deploy everything at the same time, and we're using this PaaS solution, that doesn't alleviate the concern, the feedback loop, right? So again, it's putting the batch size and the downtime trade-off too far on one end and sacrificing feedback. Because I always tell, when I just had a workshop on Monday, and I always tell my leaders, like, one of the most effective like phrases that work is, you need to decide what kind of engineer you're going to be. Either you assume that you're mostly right, or you assume that you're mostly wrong. You need to decide what kind of engineer you're going to be. If you're assuming you're mostly right, you don't need TDD, because you'll be thinking that what you designed at version 1 is good enough. If you think you're mostly right, you're not doing market research. If you think you're mostly right, you're not doing user testing. If you think you're mostly right, you're not doing regression testing. If you think you're mostly right, you come with a list of requirements and you don't validate them. You just build them front to back, back to front. Right? You just go to the list. But if you assume you're mostly wrong, which is where I'm coming from, then that means that every line of code potentially doesn't have to be built. Right? So it assumes this idea that, hey, when I'm deploying my front end and I'm deploying my backend and I'm deploying my database, if I'm assuming I'm mostly wrong, that means that there's a very high chance that this feature doesn't need to be built. So if there's a very high chance that it doesn't need to be built, if I deploy consumer side first, I can probably validate consumer side first. So I can probably deploy a front end with a fake backend, or static data, a front end with static data, or a front end that is limited to like a demo account so that it can be user tested. Mm-hmm. So I can get feedback on it to tell me, hey, we were wrong. Stop building the backend. Stop building databases. So if I'm focusing on, hey, you know what, we're good.
You can do that in the other way as well. We do.
No, you can't.
Why?
You can't, because if you wait, what do you mean other way?
We're building so many front-end features before the backend is actually developed for this. And we test it, yes. And in production, we feature flag it in shadow deployments for clients who give us feedback. And when it's good, it's basically the backend and the GraphQL API schema will be basically updated. And then we basically make another update for the front end, which connects to that things and then goes on.
The constraint works both ways, right? Mm-hmm. So what you're describing is, if I take this to the extreme and my front end team is siloed, so it's not vertically integrated, they are horizontally sliced. The teams are horizontally sliced, matching the horizontal slices of the code. Then my front end team can work much faster than my backend team. But then the constraint also applies. I don't need to deploy the front end if my team is not able to respond immediately with the backend. Right? So my assumption here is that there is one team who can do everything: front end, backend, database, product, and I'm not saying that there's one person, but like the skill completeness comes from the team collaborating.
It is one typical DevOps team for one application.
Correct. Like the team that builds it, can deploy it, can do product research, can, maybe there is something that they are like sort of facilitating outside of the team, like market research or user research, but the making the sausage like happens in the factory that packages the sausage. Like there isn't like this.
Totally agree.
Like so the idea is that if the team can observe that, hey, we're not gonna stratify our team into departments where we want the front end dev, right? So in order to make the team skill complete, we have a front end dev and 2 back end devs. We're not gonna run the front end dev at 10x velocity and just keep deploying experiments on the front end, and then the backend dev is doing like some kind of like weird push backlog from the front end person. That is also dysfunctional. That is also breaking the same constraint of consumer side first. Like, well, the consumer side has to consume the backend, but if you validate the idea, you build the backend before you build the next front end experiment, because you don't need the front end experiment if the team is busy. Right, so the team in itself is a resource that also has to be optimized for flow, but full verticality. Right, so I'm not saying this is perfect. I'm saying that if you want it simple, build it front to back, one feature at a time. But obviously, don't build it front to back and then like you have the car, the engine, and the tires. The chassis, the engine, and the tires. If I'm saying front to back, chassis, tires, engine, don't create a factory that does chassis, and then engine, and then tire. No, I'm talking about do full flow, full path to production on the entire vertical.
Mhm.
So what I'm saying is you do, instead of engine, car, instead of tire, or even engine, tire, chassis, what I'm saying is, of all the possibilities, please, the simplest minimal rule setup is please do chassis, tire, engine. Figure out which of these steps is the slowest. Get the developers together to figure out if the constraint of the slowness is necessary. Get feedback on that on full path to production, so it's actually realistic. So what you're shipping is a car, not a engine. And then optimize capacity. And then see, oh, you know what? We've optimized now. We can do 3 at the same time. We can do 3 in parallel. But only optimize for capacity once you've optimized the flow. Right. So what you're saying is, maybe if you're doing front end experiments, front, left, and center, because everything can be deployed without the backend, that is also not healthy, because that is optimizing for the capacity of what the front end team can do. And I've seen that as well in startups where the marketing team just takes over. There's like this: we're not happy with the valuation of the company, we want a higher leverage feature, and then the marketing teams take over, and they build like weird demo features that can never be implemented by the team. And they just ignore implementing it fully, and so just do like weird experiments and A/B tests. That's like fake. Like that's Theranos kind of.
If you
woo-woo.
don't use the things, yes, but
Yeah,
if you need
and
the
that's
things, it makes sense.
like the
So I
extreme side of
disagree
that is
with-
fraud, right? Where you just build weird feature flagged front end stuff.
No, I don't think so. I think that's a very healthy evolution of software, because
No,
y-
again,
I
I'm
think
talking about the
there's-
extreme. I'm talking about the extreme.
So it's not like when I say, hey, we do all those experiments, does it mean the entire company is all day long only making experiments and backend teams?
No, what I'm
doing
saying is
nothing?
that everything is an
okay.
experiment. The experiment doesn't stop on the front end level. The backend is also an experiment, right? I see a lot of
Yeah, you do that vice versa. You do that on both sides, of course.
Exactly,
So
exactly.
You do that. Sometimes you want to check out if you can get some performance,
Yeah.
if you do better caching strategies on the backend, something like that.
Yeah.
And that will be deployed basically at the same time as this front end will deploy it, something like that, because it's basically the same commit, right? Which deploys the kind of thing. So sometimes there is no new container, so it doesn't need to be actually physically be rolled in, because it's still the old artifact. But that's still okay, so it's fine. It works.
So when you say single commit, I like the monorepo approach, right? So like I find it difficult to align with you, because half of my career I worked in a non-monorepo environment, and you're working in a monorepo environment. So I get where you're coming from, but I get where you're coming from, and I also understand like the shadow side of it, right? So it's like, do I know how to do continuous delivery outside of a monorepo? Right. So my recommendation would be learn continuous delivery, learn how to do continuous delivery in your company. And if your company doesn't have a monorepo, that's fine. You can still do continuous delivery and continuous deployment. The issue of you not being able to do continuous delivery is because you don't know how to do continuous delivery. The issue isn't that you don't have a monorepo. Right? So I never want to create this impression that lack of continuous delivery is a tooling issue. It is always a mindset issue. And it is usually the mindset issue of we assume we're the kind of developer, we're the kind of engineering team, we're the kind of engineering organization that assumes to be mostly right. Which means they don't question the features, they don't question the scope, they don't question the desired level of quality, they don't question whether the user needs it, and usually they don't question the timing. Most things in continuous delivery, the example I gave earlier regarding that simple step of do build it front to back, that engages like that timing muscle of, hey, we're building this too soon. we're building this too soon. There's no demand for it yet, right? So this is a lean practice that has to do with just-in-time production. It's like we will build a front end, and then if the front end in itself with fake data is not valuable, then we will also build the back end and release it. But I won't build the back end until there is demand for it. Right? So I see a lot of teams that are stratified horizontally across layers that are creating demand for the back end, and then they're building the back end at a much faster rate than what they are actively delivering to front-end facing users. And that is a block to continuous delivery. Because your ability to show new features to the customer might actually be limited to how fast you can explain new features to them, especially if you have few demographics, right? So if your features will be part of like a release note or like a press release or some kind, if you have extreme batch sizes, then it's possible that when you release it to the users, they won't need all of them, or they won't have the mental capacity to process all of the new features. So they will only try a few. So all of the features they haven't tried were built too soon. That's where I'm coming from. Like, it's a very traditional lean kind of thinking. And I'm also applying this kind of thinking for an example you mentioned earlier. Just deploy it all at once, and ideally we can roll back. It also comes from this idea of, well, the fastest recovery time for a issue, for an incident that happened because of deployment, is rolling back. Right? So, like, move fast and break things, that works when rollback is simple. But for that to be true, your batch sizes need to be small.
Yes.
Right? Because
definitely. Yeah.
Because basically the point is that every new capability should be its own commit, and then every commit rolled out individually and prior to the next rollout used by a user. Now that's very hard to do with low traffic. Facebook can do it, which is why they had this mantra. So when they released a feature, a real user will be testing it before you could write a test for it. That's where that mantra comes from. Nowadays, they don't follow the mantra anymore because they lose a lot of money every time they mess something up. Right? So this idea that ideally what I would need is when I release a feature, I need to have a user already waiting for it, and the moment I release it, they will try it. And if they have an issue with it, I will roll it back. Now, that doesn't work very well if you're doing the minimum batch sizes, but you're just deploying them back to front. So if the user is so infrequently using your system that from their perspective, there was a batch update of 40 commits when something happened, and that is the first time you receive feedback on all of them, now you cannot roll back.
Yes.
Now, if you do a rollback, you don't know which one broke it.
You can only roll forward, and you need to find out what was actually breaking.
And now you need to do triage. Now you need to figure out, you need to do linear search on the 40 commits that the user hasn't seen yet. And you basically need to play detective of, okay, which commit was it, right? And that is not continuous delivery. That might be a rolling update kind of the delivery strategy with small batches, but the feedback loop wasn't closed. Yes, it was continuously integrated. Yes, it was deployed immediately. Yes, there was no downtime, but the feedback loop wasn't closed, right? So if the user, for example, if you're deploying to accountants, they will use a feature only, once in end of February, right? Like the flagship feature is used once by each main user end of February. Then the solution isn't to do small commits and small batches and just keep pushing everything to production, because you're a year away from the next test. Your focus for continuous delivery should be asking, how can I get this tested by a real user prior to February next year? That's the real challenge for continuous deployment, is to understand, hey, I am able to deploy faster then how fast my users can change it. How do I find a replacement for the like, it needs a meat bag, it needs a human, it needs like a real organic meat bag to give me real feedback. How do I get a substitute for that? And then do commit, release, feedback, commit, release, feedback. This idea that continuous deployment is all about commit, release, commit, release, commit, release, commit, release. That's not so important.
No one said that, actually.
No, but I mean, if you're coming from this point of let's just release everything at once, we might,
Not at once.
The
one after each other. But it's the point that first of all, if you do small batches, you break less things. And if you are
Yes.
continuously, let's say, communicating with your clients,
yes,
and you are in
that,
touch, especially in the business.
and that's the
services world.
important part. That's the
Exactly.
important
And
part.
then you know exactly what happens. Especially, so we have one client, for example, we have a big, large WhatsApp group with a lot of admins there, and
Good.
they
Yeah.
exactly know when new features are
Yes.
incrementally basically pushed towards live, right? So
Yes.
they test it, we get immediate feedback, so we can basically we
So-
have a grab on that. So we are there a step ahead. So it's not like we are blindly pushing things, and 1 month later we just need to find out 500 commits later what was actually wrong. That is not the case.
Yes, and my point is that your focus on the past solution, I understand it from a perspective of saving time to a CTO, but if you can't close the feedback loop, dog fooding the software is much more important than that past solution. That's where I'm coming from, because I'm coming from a place of people trying to update or keep uptime on their system, but nobody's like, they're not receiving feedback, and if you're not receiving feedback, that is the main problem, not that you have downtime during deployment. People often say don't release on Fridays. That's not the main concern, because they're afraid of breaking something on the weekend and they won't be there. The main issue is the inverse of that, right? The main issue is, if I deploy something now, how do I get a user to use the feature I just deployed? That is the more important concern.
But many things aren't features. It's more like changes, text changes, graphical changes, a
Of
little bit
course.
of caching changes. You can test yourself as well.
Yes.
It's not like, so we need to, it's not every commit is a feature, right?
Yes, but it all comes down to this mentality, the psychology aspect of it, of I'm building a new increment, something, a commit, it'll go out. What does negative feedback on this increment look like? Right? So what does it mean that it has to be rolled back? And I will only test for this when I'm releasing it, because all the future releases will block release. But on the first release, I will actually roll back.
I think you are in the context of deploying Fridays, and the idea that basically there is no feedback loop. People say it's not like you need to deploy on Friday. People say you should be able to deploy on Friday. That is a different thing.
I like Brian's stance on this, right? Brian uses this quote a lot about, Brian wore a pager most of his career for on-call duty. And I was, in a lot of my startups, I was also on on-call duty, not with a pager, but with and we had phones back then, so I was available on my phone.
We have WhatsApp today.
They have WhatsApp today, yeah. So it's coming from a perspective of, we have a normal release process and a hotfix, and we don't use the hotfix because it's messy and dirty, right? So Brian constantly mentions this idea of, hey, why are you using the messy and dirty release process in an emergency, right? So we have a fast way of deploying and getting feedback, and a stable way of deploying and getting feedback. If it's an emergency, I would like you to use the stable one, please. It's like, hey, if we need an urgent operation on a patient, we won't wash our hands. No. Like, if it's urgent and critical, exactly then I want you to wash your hands, right? So if one of them is fast and messy and the other one is slow and gradual, the customer won't want fast and messy when there's an issue, because they will want the slow one when there's an issue. So your hotfix procedure is too slow, and your normal rollout procedure is too slow, right? So that is the main issue. And this idea of deploying on Friday is basically, I'm not saying don't deploy on Friday because you'll have to, I don't know, it'll be in a broken state. I would say if you're rolling out a feature, freaking roll it out when you can get feedback on it. Now, sometimes features are such, sometimes commits are such that you don't get immediate feedback. There's like a lag time to you receiving feedback. Maybe your main customer cohort is very noisy and you need like a week of data to ascertain it. Okay, but that feature you won't roll back.
Yeah, but for example,
that feature you won't measure incident response with this feature has caused an incident and this feature we have rolled back based on the data we've collected for this feature. That feature you will roll back based on an incident on another feature that it has broken, right? So, but it is this mechanism that you need in place for continuous delivery that you want to use for forward and for backward.
But let's see it from this perspective. So we have last Friday released basically a minor version, an entire minor version on Friday evening, to get the feedback over the weekend.
What does minor mean? What does minor version mean?
So minor version means there is an entire new feature which is visible to everyone, and it's clear that there's a new feature in the version, right? So it's not a major update, which means it's still the same app, but you have a significant change in the the app itself. It's not a minor change. It's not a fix. It's not a label change, something like that. We're talking about there was a new, updated, very polished chat application, which is a very heavy one because there's extremely complex data in there. And we're basically releasing it because we had problems during the week with the complexity and a lot of systems, something like that. And we're basically deploying that confidently, and it wasn't breaking. And the interesting part is we got over the weekend a lot of feedback from the actual users in the field, which is actually used inside the PWA in an asynchronous offline way, and administrators on a desktop as well. And we got feedback, there were minor changes to made, something wasn't really working, but we would have the feedback as well there. And the interesting part is it's not like that we are, let's say, we are not available anymore. It's a little bit like when we make those features, we use the weekend actually because it's a very interesting time to get feedback.
Yes.
Because in that specific case, there are not too many people around using it, but those people who are around, we have contact of them. So they know how to contact us in case of something happens, or those typical power users, right? Of course, not everyone. You can't do that with everyone. But you have those specific people who let you know if something is somehow broken, but that is actually not very often the case. It is most of the time the case that you get the positive feedback about how do they think about that. Is the filtering okay? Do they find their stuff now? Those kind of things. You will get more feedback over the weekend actually than during the week because they are so stressed they don't come to actually reporting to you. And so I like to first of all stay in a state. So this is what you have mentioned. So not the hotfix way. So we actually don't have a hotfix way. We only can basically roll forward to make an update.
Yes.
And we have a short pipeline. So longest pipeline we have is 10 minutes. The shortest is 5 minutes.
Very good.
And that's so we are fine there, even if it breaks or there's something going on in the pipeline, some hiccups or something like that. We can do it again, and below 20 minutes we are actually online again. And that actually helps us a lot. So even if there is something, we could fix or change something quickly on weekend as well, but that is rarely the case, to be honest. It was some time in the beginning of the app, but it is not anymore.
So I get where you're coming from, and I think that's a very healthy attitude to have. So I'm not saying don't release. First of all, I'm not saying don't release on Friday. What I'm saying is that you should release every day, all the time. Even your work in progress, especially your work in progress.
Yes.
That is why I'm saying, from like a lean perspective, but let's just break down the example I mentioned earlier. Typical web app with the REST API front end, maybe even micro front end, front to back. If you release the database, okay, we have a
I just
comment
wanted
here
to.
from.
You can
Yeah,
go
he
on.
says
Just-
a lot of psychology behind what a customer sees in large batches. Large batches of features being released will actually intimidate users to new features rather than encourage. Yes, and there are industries where that is an exception, right? So maybe the healthcare industry would look at that. Like accountants definitely would look at this as a positive if there's new regulation and then you're aware that it's coming and there's a date, there's a deadline, and then on the deadline, all of the new regulation is being followed. That would be a healthy thing. Same thing for gaming releases, where there's hints about a new patch coming and it's going to have like this new game mode and it's going to be huge, and then there's nothing. They keep it secret. They keep spicing it up.
I don't like that at all.
I also don't like that, and that's primarily why the gaming industry is such a very extremely stressful, because you're hiding it, right? It's like releasing a movie. You don't release the movie chapter by chapter. You just release it all in one
And
go.
then you have the failed releases, never play on patch day, blah blah blah
yes.
blah blah.
You never play on patch day, and the servers don't work, and people are angry, and you need to hotfix stuff. And you need to decide, okay, now we have a cohort of users that have gained an advantage by exploiting something, and we have a cohort of users that have this feeling of missing out, right? And that I'm just saying, avoid that in your product if you can, right? So with the example of work in progress, from a waste perspective, I think if your user doesn't have access to the database, don't ship the database first. Because what feedback will it give you? It will give you feedback that the database changes are stable, but was the backend being used so that you ascertained it? Because if the user has to use the backend, then that means that you needed a human to test your backend, which means that there is a path somewhere that is not test covered. So if you needed that for feedback, that means that you could have also gotten that feedback by testing automation sooner in the pipeline. And by using
a system or something like that.
Or a staging system or something. Or just like some kind of...
I agree. So maybe that was a missing part I was not mentioning today. So we have a 2-stage setup. So we basically have a little bit like 3, 4, 5 commits staging live. 3, 4, 5 commits staging live. So
and this I like,
zone,
right? So
right?
And this follows that pattern of like the car, right? So we do the 3 parts, boom, out of staging. We do the 3 parts, boom, out of staging. We do the 3 parts, boom, out of staging.
So it is not like we would just blindly, every little thing is going to production. Especially with PWAs, you have this annoying update pop-up coming up. You don't do that like that. So you try
it's like semi-air gapped. One of my coaching clients, they develop WordPress plugins, right? So there is an element of manual deployment, because the admin of the WordPress site has to manually update the plugin, right?
Aren't there automatic updates these days?
Yes, there are automatic updates, but the automatic updates also have policies on which automatic updates are mandatory, right? So everything that is released is potentially usable by a real user, but there are also some systems that, for all points and purposes, are air-gapped to the deployment pipeline. You can't just push it onto the WordPress site of a particular user, right? Because you could use it as an attack vector, obviously, right? But this also means that it starts, like, it opens up this door of, well, if my users aren't updating, same thing with Chrome, right? What does Chrome do? Chrome doesn't auto-update. It tells you there's an update, but it does download it. That's interesting. For example, Windows doesn't, which is weird, no? Right? Windows tells you, hey, you probably need an update. And when you do need an update, it downloads the updates mid-update. Right? So it has you, for certain kinds of updates, it has you shut down everything you're doing.
You click yes and then download everything, and then it
so it closes everything, it starts downloading, and then once you start this cycle, You didn't have to make another decision to, okay, do we want to restart now to update? But now you're in this like loop where it will never stop bothering you, asking you whether you want to install the updates because you've downloaded them. And I can't roll back from this process. Now, that is still a system where there's human agency involved with installing the update. But the point is, if the user wants to install it, it's available. And more importantly, it works. Right? So it's very important that if you're in that kind of system, that you're dogfooding the updates to somebody who doesn't have a choice, which should be the employees of the company. Like they should get mandatory updates so they get to test the freaking operating system before it goes out to mainstream adoption. Like that's like dogfooding at like tier 0, and then you do canary, and then you do the people, you know, and then you do the people who said, okay, I want all the updates all the time, and then you have the people who said, I don't want automatic updates, and then you have the LTS crowd, which is, you know, the more, you know, the
Firefox LTS.
Yeah, just give me the stable stuff. Don't give me the most recent stuff. Just only give me the I want stable. Just give me the security updates and nothing else. Right?
Some enterprise clients of us had this Firefox LTS long-term stable, blah blah blah.
Yeah.
And it was so long term that it was basically not stable anymore because the entire web was working differently than this old version. But everyone still had this old version. It was so annoying.
PHP was like that as well. If you remember, you know, back in the day when Debian used to, when Debian was the dominant Linux distribution, how Debian distributed PHP packages, because it has its own subset of the package manager, Debian decided which PHP versions users get access to without installing your custom repository somewhere, right? Which means that even though PHP versions were available, it was not available for mainstream adoptions on the mainstream Linux distribution, which is a huge pain in the ass for, you know, rolling out new PHP versions, because that means that, you know, PHP, I don't know which one it was, like 5.4 was unavailable to the mainstream public for a very long time, and people were stuck on PHP 4 for a very long time because some distributions didn't want to update it because, I don't know, PHP updated, I don't know, the crypto library, and it had a dependency on something else in the system, and we didn't have Docker containers yet where you could like simulate like a fully clean environment. So whatever was running on the main server had to also using sharing libraries with your PHP setup, and then that created this whole mess of, well, like you can't update PHP. You can have MySQL or PHP, not both, and then you have to decide like how you're going to structure your server. So what I'm saying is that if you're doing continuous deployment, continuous delivery, there are some simple steps for discipline about how to build your software. But ideally, my recommendation for simple steps is build things front to back. So build steps from the perspective of what can you get feedback on from a real user. If you deploy the front end but not the back end, can you get feedback on that if the data is fake? If the answer is yes, absolutely do it. If you can deploy the back end and get feedback on it without the front end, so if you have like a PaaS or a SaaS solution that does some kind of data processing, maybe you would want to favor backend updates, even though the UI will just have the correct numbers, but it doesn't have the press release to tell you, hey, we've also fixed this number, right? So context is important, but favor the mechanism that would give you realistic feedback from a real user. Even if that real user is just a human being working for your company and you're dogfooding the solution, that's also okay. If that solution is going to a staging server, that's also okay. However, what I would disagree with, and you wrote something to me. Yeah, we need to stop. Yeah, you wrote to me an hour ago. No, you wrote to me now. Okay, good.
I know it's not that bad, man.
What I would, however, what I would not do is deploy continuously to staging, and then have like a deployment frequency asymmetry from staging to production that does not match development to staging. right? So the whole flow has to be symmetric,
Yeah,
right? So
I
that
agree.
we need to deploy from staging to production at the same rate as from development to staging. Like that flow is one flow that has to be optimized for first. So full path to production has to be optimized for first, which means that if I'm deploying a front-end feature with a feature flag to staging, it also has to go out to production.
Yeah, this is the idea. But when you read about continuous delivery, that you actually deploy once at least to production a day, which
Yeah.
means that that is the absolute minimum. So if you,
Mhm.
let's say you have 20 deploys to staging, and you need to have at least one a day to production, but that's already a hard case because there are a lot of features already going on to production. And
Again,
I would do it more often when it's
yeah,
possible.
that is that psychology thing again, right? It's like if you're building the system faster than your user can consume it, that's a good thing if you're in a releasable state. You know, that's okay for continuous delivery. But ultimately, you need to ask yourself, if you're building features faster than we can get feedback on them from a real human, did we need those features? Or are we just going through some inventory of feature requirements?
Yeah, that's true. Yeah, that's true.
Right? So that's what I would be, because if you batch them together for staging and you didn't, like each one of those individual features, so what I would ask is, would the invert have to be mandatory? So would
It
it be
depends on,
mandatory?
as I said,
Would
it
it be
depends.
mandatory for you to have 20 features before you can deploy to production?
I think that it is not that many features that you actually release. So most software teams I know don't release that many features a day. It is maybe one or two features, and those very small things I don't call them features. I just call them changes. So something is a
Yeah, yeah.
feature when you have a new functionality which wasn't there before. It's
We can call
when
it change sets. We can call it
yeah,
change sets. Yeah.
and
Like one or
so
several commits that might not be a fully fledged feature.
exactly. So
It
if
might
you
be a
if you
bug
just
fix, it might be
change
a
something.
typo.
Yeah,
Yeah.
yeah. Those kind of things are so minor to me that I don't have
Yeah.
a problem to release hundreds of them a day.
Okay.
For me, it's
Yeah.
the typical
Indeed.
feature where some functionality changes or
Mm-hmm.
a change that is so severe that the entire, let's say, as an
Mm-hmm.
existing feature is changed in its way how it's work, and
Yeah.
which means that it can break things you might not have expected, and you want to have feedback about this.
Yeah.
And you might not have seen this, your tests might have not seen this, your whatever testing has not seen this, and you
Mm-hmm.
need to get fast feedback there in order to avoid, you said canary deployments is one strategy. If you don't
So
want to have them,
Ben,
you need to get
yeah,
fast
Ben
feedback.
asked us, what CI/CD tools do I need in a startup?
Mm-hmm.
I would always come at this from a perspective of this is probably too much platform focus. I would prefer to have a conversation about users instead. But when you roll out a feature, how does the customer know? Why do they care? Because if your stakeholders, the people who write your business requirements, your feature requests, your change set requests, if they care about your product more than your users do, then there's an issue. And you're probably building a lot of software that doesn't need to be built. Now, that doesn't mean it doesn't need to be built ever, but it might just mean that you've built it too soon. Instead of maybe being able to build something you need more urgently, or increase the quality on the things that you did actually need. Right? So it has to do with capacity. 99% of the time when I'm talking to leaders, the problem isn't scope. The problem is that, yes, the things that they are building, they will need it eventually, but they're just building them too soon. Meetings that are being had way too soon, like planning meetings when the team is busy, which makes the plan unactionable because they will set a plan, but then they have to wait for the
Yeah, but
team
now we're
to.
getting in a total different area of
And now
problem.
we're getting into the total different area, but I have to preface that this area is also important
Mm-hmm.
from a Scrum perspective. Scrum was talked about 20 years ago, 30 years ago, right?
Mm-hmm.
So back then, it was normal to release once every 2 weeks. People ask me why 2 weeks in Scrum. Well, because back then, releasing that the distribution of the change sets was the bottleneck, right? So it came with this assumption that if we can release every 2 weeks, let's make sure we're not building something that takes 2 release cycles to deliver, to distribute, right? Because then it's sitting around. So let's make sure that if it takes 2 weeks to release something to our customers, because we need to print the freaking CDs or like ship the CDs by email, by snail mail, then let's make sure that every time we release, that we never do an empty release. That the snail mail can go out, can flow, and all of our code that we're shipping is being shipped for the rate of distribution, because distribution was the slowest bottleneck. Nowadays, if you want, you can do 1,000 deploys per day. I don't think distribution is the bottleneck. And coding the features also isn't the bottleneck. Because if you're coding a feature and you're not getting feedback on it, then you don't need it, right? Because you don't know if you need it, you don't know if it's valuable, you don't know who's benefiting from it. If it has a bug, you won't know. So you probably built it too soon. So when it comes to continuous delivery, continuous deployment, what is really important, first and foremost, is to have established demand and to have established some vague hypothesis for why you're building it, why you're building it right now, and what you want to learn. What you want to learn by releasing it. That would be like my minimum requirement. Now, these things are no longer simple. What I said earlier about just build the front to back and just do it with simple tooling, focus on full flow rather than uptime, that's simple. For everything else, we can have another episode when we're talking about the project management aspect, about running a company, running a product company that does continuous delivery when your users might not be ready for the rate at which you build them, for features at the rate at which you build them.
Good.
Rausschmeiße Musik. Next week we're having a discussion about AI competency. This is your chosen topic, Adrian.
Yeah.
Would you like to tease that? Tell us something about that topic.
Yeah. So there was a lot going on recently regarding new types of how AI is involved in software development, and I think the biggest problem we have is not that vibe coding exists, flow coding exists, and non-AI development exists. The biggest problem is that people tend to follow trends in this one more extensively than in any other topic right now on the market.
Yeah, so it's sexy. It's fashionable.
There is a very strange pull towards vibe coding, which isn't a big thing anyway, because the absolute vast majority of developers is still working mostly without AI. So sometimes a little bit of help, but the most actually I know are not even using agentic coding in flow coding style, really, right?
Yeah.
So what we lack is competency. What I mean by that is neither the leadership nor the actual developers really have the competency to say, what do we actually need? What is there on the market? And what does it look like when we use it with our context?
What problem are we solving?
Exactly. And for example, just, I talked about that you can start to use a little bit of ChatGPT and you see what it helps you here and there. And then you go for agentic coding and suddenly you see yourself vibing while you don't want to be vibing. And this is
we demonstrated this, right?
We are children when it comes to AI. There is suddenly something which is intelligent and we are not used to something else which is intelligent than humans. So we are used to humans. The entire generations are based on that thinking. And we still lack this thing is, what is AI? How do we actually act accordingly with AI, and how we practice with AI in an efficient way? And that is what I want to talk about, because most discussions are nonsense and meaningless, which we have right now on LinkedIn. That's one of the facts, because either people saying it's nonsense, the other people say you need to do that, it's the future, we will be replaced next year. Both of these things are basically untrue, right? So vibe coding isn't a big thing, it's just a hype, right? And the other thing is not true. So AI isn't capable of replacing us in any way. And we need to learn and understand that to understand how we leverage this new tool, but not in a way like, hey, I'm an AI coach or something like that. This is not what I mean. How to prompt correctly. This is not what I mean. Is what is AI in a, let's say, in a traditional software development space? What is it? How it basically will evolve, and how we will use it in a mature way. So we develop mature ways of working with colleagues, seniors, juniors, mentoring, those kind of things. Pull requests, those kind of things. Mature way of exchanging knowledge, these kind of things. We don't have a halfway mature way to do that with AI these days. Then the reason is that even the people who create these agentic things, they don't even know how to use it correctly. Because it is so new and so exploding that no one really grasping how to work correctly with it. And it's just so strange to see so many like certificates for AI working. That's strange to me when I see that. It is
let's put it this way. The companies that build agentic AI tools, how come they don't have a significantly larger or more exponential rate to market?
Because AI is not really helping you there to get faster to market. It is basically helping you to focus more on things. That is what helps you. So if you have bottlenecks, you were talking about a lot of bottlenecks when it comes to time to market today. AI doesn't, the specific AIs like Claude Code, which is currently still the best one, doesn't solve a problem here. So it creates a lot of inventory, if you like, but you can't get anything, and it will become legacy in the moment when you actually put that on inventory. And that is what doesn't help you. So you need to understand.
It might move the bottleneck from typing. For example, I think AI is great, and we can maybe talk about it next time. But if you're disabled and you don't have access to your hands and you can't use the keyboard, I think Claude is amazing, right? From that perspective, if I can create a scenario where the constraint is real and it is adjacent to the constraint that the Claude and the agentic tools are solving, then that is amazing. Or imagine if you were blind, you could just have Claude transcribe or even explain what's on the screen. Right? For disability purposes, sure. If it's not hallucinating. But then that's a very high standard to reach. But from a perspective of, from the engineering side, we, the humans, plus a lot of people I talk to have 20 years of experience. Everybody agrees that typing, coding is not the bottleneck. It never has been. It's the shaping of ideas, reducing the ideas, reducing scope, doing it incrementally, trying to find a pattern in how the feature is developing and how it's being used. Our assumptions are wrong, and how to incrementally build it so we don't build too much, or we don't build the wrong thing, or we don't build it too slowly thinking that we need a lot of things we don't need. That is the main bottleneck. And how much money do we need to survive while we're doing that, and what else is going on?
But let's keep this as a topic for next time. We're already discussing the entire topic, man.
Yeah.
Good, a little bit louder, then we know it's over now. Okay, awesome. Thank you everyone for listening today. It was a longer episode.
If you're in Europe, enjoy the holidays, enjoy the Labor Day extended weekend, and see you all next week.
See you everyone. Goodbye.
Bye-bye.